This is part 8 of section 3.4. And this is beyond the basics. We're going to be taking things that we just learned here about solving exponential and logarithmic equations and combine it with some stuff we've known in the past. If we're given f of x is equal to 7 plus 2 times log base 6 of 3x minus 1, we want to find f inverse of this function. Now, the process we used to find inverses is the first thing is you rewrite, instead of f of x, you write y. Okay. Our next step is to switch the x and the y. So I have x is equal to 7 plus 2 log base 6 of 3y minus 1. And now my goal is to solve for y. So I'm going to subtract 7 from both sides. Now divide both sides by 2 or multiply by 1/2, and things are going to look nicer, and you'll see why in a little bit if you write it as a fraction. Okay. Now I have a single logarithm equal to something else, so I'm going to switch this to exponential form. So I'm going to have 6 raised to all of this. Okay. Now, if I had written this instead of 1/2, I would have had 6 raised to an uglier fraction. This is just a little bit easier to keep up with, technically, mathematically the same. And this is going to equal 3y minus 1. Okay. Now add 1 to this. And now divide this by 3, and you end up with y is equal to 6 to the 1/2 times x minus 7 plus 1, all divided by 3. It's kind of ugly, but we've got it solved for y now. Our very last step is to change this y into f inverse of x. So your answer, 6 to the 1/2 times x minus 7 plus 1 over 3. Okay. Now one more. Let's solve log base 2 of x plus log base 4 of x is equal to 6. Now the big tricky thing here is that I do not have the same base. And since I do not have the same base, I cannot use our multiplication property on this to combine them into a single logarithm. I must change one of these at least. I need to use the change of base on one of them. And technically, it doesn't matter which one. You can change both of these to common log or natural log, or both to base 2 or both to base 4. It doesn't really matter, just so long as you end up with the same base. I can change them both to log base 493 if I wanted to, and I could get the correct answer. Okay? Now, I'm going to choose to change log base 4 of x. Using our change of base formula, and let's say I want to change it to log base 2, you can do log base 2 of the argument divided by log base 2 of this base. Now I can simplify a little bit here. This is log base 2 of 2 squared, and then if you use your properties, that's just simply a 2. Okay? And For our purposes, it'll be a little bit better if we write it like this. Okay. So now I'm going to take this value and plug it in right here. The equation I need to solve is log base 2 of x plus 1/2 log base 2 of x, and this is equal to 6. Okay, now what we have right here, it's really combining like terms because I have exactly log base 2 of x, log base 2 of x. That's an understood 1 right there. Just using combining like terms, I would add 1 plus 1/2 to get 3/2 log base 2 of x. Or if it helps you think of it this way, you can think of it as factoring out a log base 2 of x. And you would end up with, that would be times, sorry, I can't write. Let me start all over again. Log base 2 of x, factor that out, and you would have 1 plus 1/2, which just gives you the 3/2. Okay, so I have 3/2 log base 2 of x equal to 6. Now divide both sides by 3/2. That will give me log base 2 of x. Dividing that, 2 times 6 is 12, divided by 3. So that equals 4. Now change this to exponential form. You have x is equal to 2 to the 4th power, which is 16. Now you need to make sure that this does not give you a 0 as an argument or something less than or equal to 0 as an argument. And so both of these would be 16, so they are both valid. 16 is your answer here. So it's not that much harder, but you do have to be aware and you should start double checking that you have the same base before you start doing anything else.